Alright, we've got two lines here, and I want you to go ahead and graph both of them. So I'm going to graph this first one in blue, y equals 2x minus 1, so minus 1, and then it'll go up 2 over 1, up 2 over 1, up 2 over 1. And that gives me that line right there. Again, please draw these with a straight edge so that yours look better than mine. Then I'm going to do this line in red. So y equals 3x minus 3. So down 1, 2, 3. And then I go up 3 over 1. Up 3 over 1. Up 3 over 1. So that line is going to look something like that. Alright, and we've already talked about how where the two lines cross each other, that's the solution, where they intersect. Now, I want you to do something a little bit different. We're going to take these two equations and we're just going to add them together. Alright, so just like if it was all in one, we're going to add them together. So y plus y is 2y. 2x plus 3x is 5x. Negative 1 minus 3 is negative 4. And then I want you to go ahead and graph this one as well. So I'm going to divide everything by 2. Y is equal to 5 halves x minus 2. So minus 2, and then I'm going to go up 1, 2, 3, 4, 5, right 2. Up 1, 2, 3, 4, 5, right 2. Alright, and even though that is a terribly drawn line, what you see is that they all three lines cross each other at the same point. And because that is true, because this new equation that we came up with by adding these two together has the same solution, crosses at the same point, that means we can use adding equations as a way to solve systems. And we're going to do that in a method called elimination, which is our third way for solving systems. We want to add equations together and create opposites. So when I say opposites, I mean one of my variables, x or y, doesn't matter. We want them to have the same number, the same coefficient, alright, same coefficient, and opposite signs, because when I add them together, then they are going to be eliminated. That's why it's called elimination. So if we look at this, if I add these two equations together, x plus negative x is 0. Because this is 1, this is negative 1. 1 plus negative 1 is 0, so the x's are gone. They are eliminated from my equations. Now I have y plus 2y, which is 3y, and that's equal to 12 plus 4, which is 16. So now that I've eliminated one of my variables, I can just go ahead and solve this for y. So y is going to be equal to 16 over 3. Alright, then just like we did with substitution, we're going to take this number, 16 thirds, and substitute it into one of the equations to find what x is equal to. So I'm going to take the first one. Alright, so I'm going to rewrite it because I crossed it out over there. X plus y equals 12, and I'm going to substitute 16 thirds in for y. So x plus 16 thirds equals 12. Then I'm going to subtract 16 thirds from both sides, and I get x equals 20 thirds. So remember, for systems, you have to write everything as an ordered pair, so the solution is 20 thirds, 16 thirds. Alright. And that's how we solve things using elimination. Now, in that last example, the opposites already existed. There already was x and negative x in the equation. Sometimes we have to create opposites. We have to make the opposites happen. And we can do that by multiplying one of the equations, or sometimes we have to multiply both of the equations. So in this case, I already have x has the same coefficient. They both have 2, but I need one of them to be a negative 2 so that when I eliminate, it will actually eliminate, because right now if I added them together, 2 plus 2 would be 4. So I'm going to take one equation and multiply everything by negative 1. It doesn't matter which one. I'm just going to pick the first one. Alright, and what you have to remember is you have to multiply both sides by -1. Alright, so everything gets multiplied by -1. -1 times 2x is -2x. -1 times 4y is -4y. And -1 times 8 is -8. So now, here are my two equations that I'm going to add together. 2x plus -2x is 0, so they are eliminated. 3y minus 4y is -1y. And -12 minus 8 is -20. I'm going to solve for y. I'm going to divide by -1. So y is equal to 20. Now I'm going to take that 20 and plug it into one of the equations. Doesn't really matter which one, so I'll just go with the first one. So I have 2x plus 4 times 20, and that's going to be equal to 8. So 2x plus 80 equals 8. Subtract 80 from both sides. 2x equals -72, and then when I divide by 2, I get x equals -36. Alright, you cannot leave your answers like that. An answer to a system has to be an ordered pair. So it is -36, 20. That is the solution to that system. Alright, in the first example, the opposites were already done for us. They existed in the equation. In the second example, we just had to multiply by -1. Sometimes, if you look at this case, I don't have the same numbers. I don't have opposite signs anywhere. So sometimes you have to multiply by something other than just -1. Alright. In this case, I have two options. I could multiply everything in the first equation by -3, because then that would give me -3x and 3x, so my opposites. Or I could multiply everything in the second equation by -2, because then I would have -4y and +4y. It makes no difference which one, so just pick one and go with it. I'm going to go with the first option, so I'm going to multiply everything in the first equation by -3 to create my opposites. So now I have -3x minus 12y, and that's going to be equal to +24. So I'm done with this equation. Now here are my two that I'm going to add together to eliminate. So 3x minus 3x is 0. 2y minus 12y is -10y. 6 plus 24 is 30. Now I'm going to solve for y. And I get y is equal to -3. So there's 1/2 of my solution. To get the next half, I'm just going to plug it in. Again, doesn't matter which equation, I'm just going to go with the first one. So I have x plus 4 times -3 equals -8. So x minus 12 equals -8. Add 12 to both sides. X equals 4. So my solution is an ordered pair, 4, -3. And just like we've been doing since the beginning, you have two methods that you can use to check that answer. You can plug it back into both equations, or you can graph it and let your calculator help you check. Then we're going to look at one more example. The most complicated kind of elimination is when we have to multiply both equations. And sometimes that happens. If you look here, I don't have the same coefficients anywhere, and I don't have opposites anywhere. But I can't multiply 4 times something and get 6 as an answer. I can't multiply 6 times something and get 8 as an answer. So in this case, I'm going to have to multiply both equations. And the easiest thing to do here is pick a variable that you're going to eliminate and then multiply them by the coefficient from the other equation. So in this example, if we're going to eliminate the x's, alright, I'm going to multiply the first equation by this coefficient, so by 4. Alright, and then I'm going to multiply the second equation by the first coefficient, or 6. And I need to make one of them negative so that they will eliminate. Doesn't matter which one, just pick one. Alright, so I'll go with the first one. So now my new equations are going to be -24x plus 32y equals 200. And on the bottom, I'm going to have 24x plus 36y is equal to 132. So I multiplied everything in the top by -4, which will make this a -200. Hopefully you caught that before I did. And then everything in the bottom by 6. And here are my two new equations. I have my opposites, so I can go ahead and add together. So -24x plus 24x is 0. They are eliminated. 32y plus 36y is 68y. And that's going to be equal to -200 plus 132, which is -68. Solve for y, I have to divide by 68. So y is going to be equal to -1. And then again, I got to take that -1 and plug it back in so that I can get the other half of the equation. So 6x minus 8 times -1 equals 50. Alright, and now we have to solve for x. So 6x plus 8 equals 50. Subtract 8 from both sides. 6x equals 42. Divide by 6. And x is equal to 7. So my solution is 7, -1. Alright. I did for the beginning, I did the odd example, so I did example 1 and 3. I want you to go back and do examples 2 and 4 from the other page of elimination problems. And then when we get to class, we will go over the answer to those. So work through those problems, check your answers on the calculator or by plugging in, and if you have questions, make sure you write them down so that we can get to them in class.